Right, November 17, numeracy non-calculator. So first question is about two schools and how people get to school, whether they cycle or not. So questions to go with it. Which school in year group has approximately an equal split? So if we look across the 8 bars, you can see that it's the year 10 from Ysgol Caiwen that have got the equal split between the 3 categories. So that is our answer to the question. So we've got Ysgol Caiwen, and it's the year 10 group. So there are definitely more pupils in Ysgol Front Isa who cycle than Ysgol Caiwen. So can we see from this whether there are more or not? We don't know whether there definitely are, because all we're told about is a percentage of the pupils and we don't know how many pupils there are. So that statement is false. Both schools have pupils in each year group with no interest in cycling. So the white bars represent that, and you can see there's a white bar for all 8. The questions asked were biased. So if we look at the questions, do you cycle to school? Yes or no, there's nothing biased about that. If you answered no, would you like to? Yes or no, there's nothing biased about that. They're not leading people into certain answers, so those questions are not biased, so that statement is false. Approximately 20% of the people surveyed in Ysgol Caiwen cycle. So if we look at Ysgol Caiwen, you can see 20% of year 7 do, 20% of year 8 do, just over 10% of year 9 do, and just over 30% of year 10 do. So approximately that would be 20% across the board, so that is true. It is more likely that it is Ysgol Front Isa that's the small school in a town than Ysgol Caiwen. So a small school in a town, you would expect more people to cycle than in a rural area where they've obviously got further to travel, and you can see that Ysgol Front Isa has a lot more people cycling every year group, so I would suggest that that is true. In January 2011, 1,200 miles of National Cycle Network, 1,416. How many would you expect in 2018? So that shows that in a 5-year period, it's increased by 200 miles. So then that would suggest in a 1-year period, there's an increase of 40 miles. So in a 2-year period, there's an increase of 80 miles. So you could assume that in 2018, there would be 1,480 miles of cycle network. Question II, why is your answer unlikely to be an accurate estimate of how many miles there are? Because we've assumed here that it's a linear increase. We've assumed that it's going at 40 miles every year. It's probably not the case. So we're going to put something along the lines of that it's not going up the same every year. We don't know that it's the same every year. It's the fact that we've assumed that there's a linear increase in the amount of miles each year. So it goes up the same every time, when in reality that's probably not true. Question 2. William owns kennels. Why does it not pass through the origin? So, if there are no dogs in, there's a cost of £10. Why is there a cost of £10 running it when there's no dogs there? Because obviously he has to pay for other things like electric, light, water, heat, power generally. So it's the running cost. So that are the running costs of the business. So it's irrelevant of how many dogs are in there. He has to maintain the building. What is the increase in the daily running cost for each additional dog? So pick any 2 numbers of dogs that are next to each other and work out the cost. So if we look at 10, that's a cost of £50. And if we look at 11, that's a cost of £55. So that's an increase of £5. So 10 dogs would cost £50. And if we look at 11 dogs, that's going to cost £55. So 1 dog extra is £5. Frida also runs a kennels. The cost of keeping 20 in her is £130. She knows that as the number increases, the overall cost increases at the same rate as in Williams. Display this on the graph paper. So for 20 dogs, she charges £130. So that's what she would charge for 10 dogs. There's a couple of ways how you can ensure your line is at the same rate now. You can either count how many squares there are from Williams' line to where we've put that, which are 2, 3, 4, 5, 6, 7, 8, and then just pick another point and count 8 squares up again. 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be there. And then join those 2 points up and they will be a linear line which is the exact same distance apart each time, so the rate has increased equally. Find the cost of keeping 30 dogs for a day in Frida's kennel. So now we've drawn the line for Frida, we can just go up to 30 and we can draw across from there and we can see that that's £170. So it'll be £170. Question number 3 about a cumulative frequency diagram. Find the median. So the median is found by looking halfway through the data. So there's 120 people, so if we go across at 60, we'll find the median for that set of data. So at 60, because that's halfway, we find the median. And remember, 60 isn't the median. We need to draw down from the diagram, and we need to read off the time at the bottom. So we've got 15, 15 and a half, 16, 16 and a half, 17 minutes is going to be the median. And then for the interquartile range, we need to go 3/4 of the way through the data, which would be 90. And that is our upper quartile. And we go 1/3 of the way through, 1/4 of the way through the data, sorry, which would be 30 people, which is our lower quartile. And then again, we read the values of the time at each of those points. So we draw a line down there, and we can see that's at 19 minutes. And we draw a line down here, which we can see comes in at 14 minutes. And then to find the interquartile range, we do the upper quartile and we subtract from it the lower quartile. So we find that the interquartile range is 5 minutes. Marion looks back at his raw data. He finds that the median is actually 17 minutes and 30 seconds. Why is there a difference between it from his graph and the actual median of his raw data? So when he uses his raw data, it's perfectly accurate because he takes every point into consideration individually. When we look at it as a graph, we've grouped data to start with. So to plot a frequency, cumulative frequency, we've grouped data. So we've grouped all of the people between 0 and 5 minutes into here, 5 and 10 here, 10 and 15. So we've lost a little bit of accuracy there. And the other reason we've lost a little bit of accuracy is because we've used straight lines here, whereas realistically they would be slightly curved if you were to draw it more accurately. So it's about data being compressed and lost. So it's to do with data lost when it's grouped. So the data has been lost slightly when it was grouped. Marion is looking at the time it took to clean. Find the number of customers whose windows took between 10 and 15 minutes. So what a cumulative frequency diagram tells you is how many people were less than a certain time. So this point here tells you how many people took less than 15 minutes. And if we look across from there, we can see that's 34 people. So 15 minutes, we had 34 people. So within 15 minutes, 34 people's windows had been cleaned. If we do the same for 10 minutes, we see that that comes in at 12. Now, these 12 are included in this 34 because it's a run-in total, so we can see there's 22 that were cleaned longer than 10 minutes but less than 15, so it would be 22 customers. Marion thinks that for approximately 80% of his customers, he cleaned their windows in less than 20 minutes. Is he correct? So there are two ways we can do this. We can look at how many people were cleaned within 20 minutes, or we can find out what 20% is and see if that comes in at a value of less than 20 minutes. So I'm going to do it that way. So 80% of his customers, so if 120 were everybody, 80% of 120 is going to give you 96. So we need to find out how long it took for the 96th customer's windows to be cleaned. So if we draw a line across at 96, which is going to be there, if we draw a line across and then we draw a line down, as long as this is below 20 minutes, he is correct. So you can see that that comes in at 19.5 minutes. So 80% cleaned within 19.5 minutes. So yes, he is correct that 80% are seen within 20 minutes. Question 4, the gas bill or electric bill. The price is increasing by 5%. So at the moment it's 20p. So 10% of that would be 2 pence. So 5% would be 1 pence. So it's a 21 pence cost. So part B is asking you to work out the cost.